Welcome, Pete, and give us an overview of Uniper.
Okay, so Uniper is a new name, but an old company in that sense. So we were born from the UK Central Electricity Generating Board, the CEGB. After that, we were Powergen, and then after that, we became E.ON. And from that basis, we've had a long history of understanding how power generation works through a challenging European market, the most advanced market in the world in the sense of renewables penetration. We're getting to levels of probably nearly 70% during this low demand period during the lockdown in the UK. So through that transition, we've effectively altered how our assets operate. And for us to be able to alter how they operate, we've also had to build tools, solutions, which are a combination of software and engineering expertise to actually meet these needs. So 30 years ago, we did thermodynamic modeling, and we built our own tools for that because there wasn't what we needed on the market. 25 years ago, we did online vibration monitoring again, because there wasn't the tools on the market. We built our own. 20 years ago was complex market modeling, so with the liberalization of European markets in the energy sector. 15 years ago, we did holistic risk management, so not just financial, but technical, environmental, safety, publicity. So you can effectively choose what the right investment is to make across those set of risks. 10 years ago, we did advanced condition monitoring. Before it was called, we're doing it before it was called machine learning. 5 years ago, we did maintenance optimization. And every single one of those situations was driven by a changing market, us needing to improve our operation and our asset management, and the tools not being available for us. So we had to build our own. And then 2 or 3 years ago, when we became Uniper, we had a strategic decision to make. Do we downsize our engineering business to match our existing remaining fleet from E.ON, or do we look to grow our competence and help the rest of the world in their energy transition? Because honestly speaking, the world is going through a significant energy transition, and we've got the knowledge, expertise and solutions to do that and help those companies and countries and people achieve that. And we package that all together in the analytics platform.
Can you give us a brief overview on the different operating regimes and how can companies extract value now and in the future?
Yeah, that's a really good point and question, because it does change over time. But what doesn't change is the solution. It's just how you use that solution. So let's say you're near the beginning of a large asset's life cycle, would be predominantly baseload generation. At this point, you're looking for thermodynamic efficiencies. You're looking to effectively drive down your cost base and get the highest output, and that will get you the most revenue. Then over time, generally the first thing we see is people stop chasing top-end megawatts, so they're not looking at pure efficiency. If they're starting to do that, they're at the beginning of their flexible generation journey. So when that happens, then you'll start thinking about, how do I bring my assets minimum load down as low as I can? That then becomes a thermodynamic problem, and you want to bring in some advanced condition monitoring, because you're going to bring assets into operating regimes that the design documents don't exist for. So you then need to use that thermodynamic model and previous modes of operation close to that range to tell you, is it operating within normal and is it safe to continue to operate? And then if we go a step further, you'll then start flexing the asset, doing multiple starts, multiple stops per year. I take, for example, Ratcliffe Power Station. It's a coal-fired asset. It will be the last remaining coal-fired asset in the UK, as there's only 3 currently left. With that being the last remaining coal-fired asset, we have had to look at the number of starts and driving the cost down on a start. So Ratcliffe was designed to do 3 or 4 a year. And we get close to 1 year, we've done over 100 starts per unit. And those costs for a start are quite high. So doing your thermodynamic performance, your general broader performance in terms of oil usage and operations strategies, that is different from when you originally used those tool sets under a base load. So depending on the operating regime, each solution will give you varying benefits. And we've seen over time that even if you put a solution in today, you're still going to get benefit in the future as that mode of operation changes.
Got it. So can you talk about the engineering job market and the skills levels and competencies affecting the industry ability to safely run the power plants?
Yeah. So, when a large number of these power stations were built, particularly in Europe in the 60s, 70s, 80s, and then 90s with the dash for gas, particularly in the UK, and then later in the 2000s with the renewables push, and in the 2010 we kind of peaking flexible gas assets. What's happened over that time is engineering in particular has had a big competition with fintech companies, with financial companies, with general tech companies, because engineers, their competence, their knowledge with regards to mathematics, understanding complex problems, ability to solve problems, is in high demand by those sectors. And if you look at the previous top 10 market capitalized companies 30 years ago, none of the tech players were in there, with maybe the exception of Microsoft appearing. And now the top 10 is 8 or 9 of the top 10 are tech players. So we see that effectively those talents that were previously available are in competition with other, what in my opinion, more boring sectors. If you want real challenge, the energy challenge is the greatest challenge this planet currently has with regards to climate change, but we just can't compete financially in that sense. So they're a big competition. And the other one is the industry has historically and continues to look after people. We give people good benefits, good flexible working, good basis of pay, good pension. They are superb companies to work for in the energy sector. But as a result of that, that means that there has been a number of early retirements, because people can rightfully early retire and enjoy the life of leisure they deserve. And with that and the competition the other way, there is a declining basis of knowledge in the industry. And that becomes even more prevalent as you go through a flexible operating regime and a change in operations. How do you continue to safely operate? So with those forces of competition and declining workforce, how do you get the best out of your assets to continue safely operate? And that's where the digital solutions come in. So analytics embodies all of our knowledge, expertise we've built over the past 30 years. And it provides that knowledge and access to countries, to people, to places that haven't had the opportunity to build up the knowledge and make the mistakes and learnings that we've had over the last 25, 30 years.
Got it. Thank you for that insights. Now, we talked about the AI and machine learning in the beginning, and obviously we know that it's having a strong impact in other industries like retail and consumers. Can you expand on the energy sector and why isn't having such an impact, and where can organizations find values in those technologies?
For me, there's 3 really important things around AI and machine learning that is not widely understood, but should be widely understood in my opinion. The first one is that machine learning and AI needs lots of data. I mean, like loads of it. To make that a bit realer, human beings are amazing, low information, low context learners. So if you or I saw a duck-billed platypus, we would think, well, that's a bit of a weird animal, but I kind of know what it's going to do and what it is. But if a computer for the first time sees a duck-billed platypus, it's going to be like, oh, I've got no idea. Is this thing a chicken? Is it a duck? Is it a beaver? Is it a water owl? It doesn't have any idea. It would need to see tens, hundreds of thousands of images to know that this is a duck-billed platypus. And you could say the same with a Segway. You know, it's the Segway, this weird thing that you kind of stand on and you move and it drives. But a computer, if it's never seen one before, it doesn't know what that is. And that's one of the great problems with the power sector. There are a number of known failure modes, but thankfully we don't have tens of thousands, hundreds of failures because of the safe way that assets rightfully operate. And with that in mind, you can't necessarily use failures as a basis to learn from, whereas you can where you're building washing machines and you're building thousands of the things, and they're reasonably simple engineering basis as in comparison to a large power generation asset. So that's the second thing. The third thing is around the risk element. So power stations, particularly thermodynamic reactions and thermodynamic basis, they are operating at temperatures, pressures that are extremely high, borderline, highest on the natural face of the earth. And as a result of that, any mistakes that are made are catastrophic. And we at Uniper, we pride ourselves on a safety first culture. We want everyone to go home healthily and safely. With that in mind, the risk appetite for asset owners is a lot less than, say, a retail sector. That's not meant disrespectfully. It's meant that if you do some clustering of customers, if you get it right 80% of the time and you lose 20% of the customers, that's fine because you're getting more customers than you had. But you can't be right 80% of the time in the power station because you can't afford to damage 1 out of 5 assets. It's just not socially, economically and safely acceptable. So with those 3 things in mind, it basically means that it's very hard for non-energy experts, non-engineering experts and startups to enter the sector because there isn't the freely available data. There is the complex nature of the assets and the build-up of information data you have to have over 10s, 20s, 30s, 40s, 50s of years. And that's what we've got, thankfully, at Uniper, having run our own asset base of 35 plus gigawatts over the past near 50 odd, 60 odd years. And with that, we're able to use those 10 years, for example, of condition monitoring. We've kept every single fault that we've ever found on a power plant. And for the 25 years of vibration, we've kept information, every single fault that we've had on that power plant. So we've now got a pseudo list of failures. So they haven't failed because we've caught them, but they're like a pseudo failure. So we can use that data set, which is large enough to start to predict modes of failure and what failures are going to come from an asset. And you don't get that as a startup. You just get that naturally because of history. And that's the fortunate place that the Uniper finds itself in. And that's for me why startups and other disruptive groups haven't been able to penetrate the power generation side of the energy sector. It's not that it's not possible, it's just they don't have the resource to achieve that.
Got it. Thank you very much for the insights. And for the audience out there, if you'd like to learn more about AI in the energy sector and machine learning, feel free to join the PEAT session during the IIoT World Days, and you can sign up at the link that will be displayed on the screen.
Thank you.